Hello everyone, today I am going to discuss a binomial theorem. What is the meaning of binomial theorem? Just take a word binomial and divide in two parts, that is bi and nomial. Bi means two, nomial means term. So by using this theorem we can perform a two variable operations. Take an example here. What we have? 103 raised to 2. This 2 indicates number of multiplication we should have to perform as a base value. Base value here we have a 103. So just apply a general multiplication, that is 103 into 103. You will get a after multiplication as the answer 10609. One more alternative method we have, that is this 103 we can divide in a two numerical number, that is 100 plus 3. After addition of these two we will get the same as it is 103 only. So this one will be the standard form we have, that is a plus b whole square formula, that we have a square plus 2ab plus b square. Wherever we have a, just substitute as 100 and b as 3. After simplification of this one, you will get an answer as 10609. Take a one more example. Here also we have taken 103, but the power value we have taken 3. So after multiplication, we'll get a first value will be 10609. Again we have to multiply a 103. Then we have final answer we are getting as 1092727. So additional as alternating method for this one, what we have 100 plus 3, but at this time we should have to take a power as 3. So this one will be the form of a cube plus 3a square b plus 3ab square plus b cube form. So wherever you have a, just substitute as 100, and wherever we have a b, just substitute as 3. After simplification we will get an answer as 1092727. This one will be the similar answer we have got it from the general multiplication. Is it possible to calculate 103 raised to 7? So this one will be a little bit difficult as compared to the last previous one, that is power of 2 power of 3. So n number of power we can calculate or we can write the formula also by using a binomial theorem. So here we have a binomial expansion, that is a plus b whole raised to 0. So anything value raised to 0, it will give an answer as always 1. Second one we have a plus b whole raised to 1. If we have a power as 1, this one will give a same as it is base value, that is a plus b. Next third one we have a plus b whole square we have. For this one we have a formula a square plus 2ab plus b square. Next we have a plus b raised to 3. For this we have a formula a cube plus 3a square b plus 3ab square plus b cube. Next we have a plus b whole raised to 4. For this one we have a formula a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. Up to n number of power we can take it as an expansion. So general formula we have as a plus b whole raised to n. So whatever we have a constant value, how we are going to write the constant in terms of formula? For that to know, we have a middle term, that is take it as a 1 and shift it in a second row as it is 1 1 at the corner part. And then third row again you just at the corner part shift it 1 only, but middle one you just take it 1 plus 1, you will get an answer as 2. And then again shift it 1 1 at the corner part, and then fourth row what we have second constant, that is 1 plus 2 you will get 3, 2 plus 1 you will get 3. Next shift it against once in a corner part 1 as it is, then we have a second constant as 1 plus 3 as a 4, 3 plus 3 as a 6, 3 plus 1 as a 4. Again you shifted 1 at the corner part, and second constant 1 plus 4 as a 5, 4 plus 6 as a 10, 6 plus 4 as a 10, 4 plus 1 as a 5. This first row indicates what? Just compare it in terms of table here. What we have? First row we have a 1. So this one indicates for 1 a plus b whole raised to 0. Second row what we have? 1 1 as a constant, that is It indicates a power a plus b whole raised to 1 where we have a constant as 1 1. If you are not writing any 1, that will be considered as 1 only. Take it third row in a triangle, that is 1 2 1. This one will be the a plus b whole raised to 2. We have a formula as constant 1 2 1. So based on this triangle, we can write it the constant in terms of table. So up to a power, that is 50, 75, beyond 80, we can take it a power, but it is difficult to operate in terms of triangle, because at the starting only we should have to start a triangle, and up to 75, 80, 85 we have to extend it. So that will be a little bit difficult. To become a easy, here we are using a factorial method. Just take it a first row. That first row we have a first only one constant, that also we can write it in terms of factorial method, that is 0c0. Second row, what we have, 1 1 as a constant. For a first constant, as a factorial method, we can write it 1c0. Here 1 indicates what, power value, and 0 indicates first constant. And second constant, we can write it 1c1. 1 indicates a power, and second c as a base 1, whatever we have, that indicates the second constant. Take it the third row, where we have this one will be the a plus b whole raised to 2 formula, right? So there we have got a constant 1 2 1. This first constant can be written in terms of factorial method as 2c0. Here 2 indicates the power a plus b whole raised to 2. We have that power 2 here we have to write, and 0 indicates the first constant, and second constant we can write it 2c1 as a 2 constant value, and third constant we have a 1 that can be written as factorial method 2c2. So this one up to a plus b whole raised to 5 we have taken. So just take a one example here. So 5c3 in terms of a last row, that is a 4 constant, we have 5c3. As per the triangle we know the value, it will be 10. But by using a factorial method we can calculate and compare with the triangle, so that we will get an answer same as it is or not, we'll check it. Okay, so 5c3, this one as a factorial method we can take it 5 factorial divided by 3 factorial, then 5 minus 3 factorial. This 5 factorial can be written in a decreasing order, that is 5 into 4 into 3 into 2 into 1, but don't take it as a 0 here. If you take a 0, then overall value becomes 0 only, divided by what we have, 3 factorial, which means 3 into 2 into 1, and next 5 minus 3 means 2, that you have to take 2 into 1. After simplification of this one, you will get a 10. Just compare this answer with a triangle. There also we have a 10. So by using a factorial method also, easily we can calculate the constant of in the formula also. So we have a general term, how we are going to write the formula, that is a plus b whole raised to n, how we are going to write. So just take a first variable as a and start it from the left side with the same power, that is n only, and write it from left to right side in a decreasing order, that is a raised to n plus a raised to n minus 1, then plus a raised to n minus 2 plus a raised to n minus 3, and lastly you will get a raised to 1, that will be writing as a, plus a raised to 0. A raised to 0 is nothing but what? 1 only. So add b raised to n multiplying with a raised to 0, we should have to write actually. A raised to 0 is nothing but 1 only. If you are not writing any 1, that will be considered as 1 only. Then we have a second variable as b, that we are writing from the right to left side, that is the same power we are going to take it here, that is b raised to n, b raised to n minus 1, b raised to n minus 2, b raised to n minus 3, up to where, that is b raised to 3, b raised to 2, b. Here b is nothing but what? B raised to 1 only. B raised to 1 is nothing but b only. Next we have b raised to 0, that is nothing but 1. If you are not writing any value 1, that will be okay. Next, what about the constant we have to write? Okay, so for that we have a factorial method, that is first constant we can write it nc0, second constant we can write it nc1, third constant we can write it nc2. So up to where we can write nc n minus 1, nc, n. So at the last one, we'll get a power value and a constant value will be the same. So next we'll take some properties of binomial coefficient. So just we have taken a formula as a general one, a plus b whole raised to n. Just in previous slides we have taken same as it is, you just take it. Next one more formula we have, that is a minus b whole raised to n. So in this just compare it with a plus b and a minus b formula. Just we have a sign changing, that is first one we have a plus sign, second one we have a minus sign. Okay, so in that to writing a formula, overall concept will be the same, but only thing due to a sign, negative sign, we have to follow a sequence positive, negative order in terms of a minus b whole raised to n formula. So we can say it, first constant we have a positive sign, second constant we have a negative sign, again a third constant we have a positive, and fourth constant we have a negative. We can say it, odd constant, overall odd constant will be a positive sign, and overall negative sign will be the that is negative sign indicates that it will be a even constant, we can write it in terms of negative sign. So next property what we have, just we should have to subtract a plus b and a minus b. So you just observe it here. At the second constant, first one will be a positive, and in terms of a minus b whole raised to n, we have a negative sign. So this one will be cancelled each other if you do a addition of this operation that we have taken here. That is a plus b whole raised to n plus a minus b whole raised to n equal to, here all the odd constant will be cancelled each other, but what about the even one will remain same, that will be the 2 times we are getting, that will 2 in a bracket nc0 b raised to 0 plus nc2 a raised to n minus 2 b raised to 0 b raised to 2 we are getting. Next we have one more property, that is a plus b whole raised to n minus a minus b whole raised to n we have. So in this one, all the even constant will be cancelled, and final one we are getting 2 times of odd constant, that is b1, b3, b5, b7 all remains constant. Third property we have a plus b whole raised to n general formula. As per the observation of this formula, we can say it, number of terms at the right side will be n plus 1. Here n indicates the power. Just take an example of a plus b whole raised to 2. Whole raised to 2 means power value will be 2. What about the formula we have? A square plus 2ab plus b square. At the right side we are getting 3 terms. So we can say it, number of terms we are getting at the right side will be n plus 1 as compared to the power. Next we have a binomial theorem for any index. Any index we can take it a general formula as a plus b whole raised to n and a minus b whole raised to n form. So this theorem we can apply it for any index. Thanks for the watching. Please like, share and subscribe for the more videos.